everybody, it's Mrs. Pound, and we are still talking about weather in Chapter 5.2. And today's topic is going to be global winds from Section 524. So, our objectives today are to identify and explain three global wind patterns and to apply the Coriolis effect to global travel. So, the first winds I want to talk about are the trade winds, and they're called the trade winds because these were the winds that carried most of the ships, sailing vessels, for trade. So, for the trade winds, these are winds where the warm air rises at the equator. It creates an area of low pressure and moves towards the poles. So, these are near the equator. At 30 degrees latitude, the air sinks, producing a high, and then returns to the equator. So we have a convection current going on here, okay? There's this convection current. And I'm going to show you this in your reference tables after I'm done going over each of these. There are also the polar easterlies. And just looking at the name, these happen at the poles. So what happens is cold air sinks at the poles, producing an area of high pressure and moves toward the equator. At about 60 degrees latitude, the warm air rises, producing a low, and returns to the pole. So we have another convection current, and this is the trade winds are on each side of the equator. The polar easterlies are in the north and at the south pole. And then we have the westerlies. The westerlies are sandwiched between the trade winds and the polar easterlies. These happen between 30 degrees and 60 degrees latitude. They're actually due to movements of the trade winds and the polar easterlies. Now, at the surface, winds blow toward the poles. And in the upper troposphere, the winds blow toward the equator. And you'll also notice when I show you the map that because of the Coriolis effect, the wind paths curve. This is due to the fact that as the Earth is turning, the equator moves faster than the poles. And so even though the winds technically are in a straight line, they appear to curve because different parts of the earth are traveling at different speeds. And I will demonstrate this to you in class. So how that applies to plane travel is if a plane were to travel straight south from the equator to Antarctica, its path would appear to bend toward the east. Okay, it would bend toward the east. And that is due to the fact that the earth is moving at different rates below it. The same would occur if the plane was traveling from the equator to the North Pole, except for in that case, it would appear that its path would bend toward the west. It would be the opposite. Okay, so this is on page 14 of your reference tables, and the names of the winds are not labeled, so you will have to remember that part. But I'll give you some hints for that. So here around the equator we have our trade winds. We have our westerlies just above the trade winds. And then at the poles we have our polar easterlies. Now, what we have to remember is the westerlies, if we look at this, the wind comes out of the west for the most part, okay? And for the easterlies, the wind comes out of the east. So that's how you'll remember easterlies and westerlies. It's where the wind comes from. Just like our local breezes and winds, we name the wind for where it comes from. We also see here those convection currents. So here at the equator, that warm air is rising, it cools, it sinks. So we have a low, we produce a high, we have a nice convection current going around here for our trade winds. Up here, I'm going to go to the polarlies. So at the poles, we have some dense air sinking, okay? The air warms, it rises. We have a nice convection current here. So we have a high, we have a low. And remember, We always move from the high to the low when we're producing our convection currents. Now, the westerlies are a result of these two other winds. They just basically are produced from the trade winds and the polar easterlies. And so we here because air is sinking here, that produces a current here that produces sinking air. And because the air is rising for the polarlies here, it pushes that up there. So we get a convection current here for our westerlies. So that's where they come from. We also see that between these convection currents, we had talked about jet streams previously. That's where the jet streams are located between these convection currents, between the westerlies and the polar easterlies and the westerlies and the trade winds. You can see the jet streams. Also here you will see that because of the way these winds act, we have a very wet area because we have, remember, low pressure brings in stormy weather. So because we have an area of low pressure here, it tends to be very wet. Because we have high pressure here, these areas tend to be very dry. Remember, high pressure, basically clear skies. And again, up here at 60 degrees north and south, again, another wet area because we have an area of low pressure that's relatively permanent. So these are some things that you can get from this map so that you don't have to memorize everything. Also see, I talked about the Coriolis effect. You can see the way these winds curve. If the Earth was not spherical, if it all traveled at the same speed, these winds would simply go straight. Okay, they would go straight down, but because of the different speeds at which the Earth is traveling as it rotates, we get this curved effect. And say right here, if you're traveling from the equator to Antarctica, you could see we could use the westerlies down here to distinguish that they will curve east, okay? And if we likewise were traveling from the equator to the poles, we can see that our travel would be just like the westerlies up here, and so we would appear to be going more, we would bend east, and our path would look curved even though it's straight. So it would appear curved from the ground, and we would land in a different location than we anticipated if we did not account for that. So our objectives for today's video to identify and explain 3 global wind patterns and to apply the Coriolis effect to global travel. Now, if you're listening, what I want you to do is I want you to put a star, a big star, next to the westerlies because that is where we are located. We are located in the westerlies because predominantly most of our winds, unless there's a storm, and I'll talk about how that affects it, predominantly most of our winds and our weather come from the west because of the westerlies. So don't forget your 5 questions, and I will be back with more about weather.